and welcome to today's daily Leetcode challenge. We'll be solving question 34. Find first and last position of element in sorted array. I'll be going through my thought process as I come up with the solution, then stick around for the end of the video where I compare my solution to the solution of others. Let's begin. So given an array of integers, nums, sorted in a non-decreasing order, so it's going to be increasing, find the starting and the ending positions of a given target value. Okay, so in a sorted increasing array, we have to find the beginning and end of some value, of some target. If target is not found, return -1, -1. You must write an algorithm in O log n runtime complexity. Awesome. So this is probably the more the complicated that portion of this question that makes it complicated. Otherwise, you would have just went through the array, found the first occurrence and the last occurrence. If none, you would return -1 for both starting and ending position. Cool. Let's look at some examples. We're given nums and the target of 8. So we want 0, 1, 2, 3, and 4. We want the answer to be 3 and 4. Awesome. That's what we have here. Then we're given 5, 7, 7, 8, 8, 10, and we're looking for a target of 6. It's not nowhere to be found, so -1, -1. And the rest, yes, it's an empty array, so it's just -1. So I guess it's a pretty dead giveaway that this is going to be binary search. We need to use binary search to find the starting and the ending position. The hard part, the difficult part is binary search usually just finds a number, an occurrence. You can modify the algorithm a bit to find the first occurrence, but also there's very rarely do you find the last occurrence of a element in using binary search. So what I'm going to, I guess, do is what I want to do is I want to find using binary search the first element, and let me give just an example of what the first element would mean in this case. First element would just mean the one here, not just any one of these, but specifically the first element. And I'm going to show you how to do that. And then basically just do the same thing. Use the same, almost the same binary search, but to find this element here. There's going to be slight modifications to the way the algorithm is written. But let's begin. Again, maybe some reiteration for all of you, but binary search cuts on each iteration, cuts the array that you're looking for in half, and eventually you're supposed to end up on the element that you are looking for. You do this with something like this, while start is less than end. Both of start and end initially pointing at 0 and end pointing at len of nums if you want to do exclusive, but if you want to do inclusive, you would do -1. What I mean by that is end would actually be pointing to the last element, not to the external portion of the array. And while start is equal to end, you would do something like this. Mid is equal to start plus end divided by 2. And then you would say if target is smaller, for example, or equal to nums mid, you would do something, and then else you would also do something. So, and actually what's going to happen is both this condition right here and this condition is going to change based on if we're trying to find if we're trying to find the left or the right. And with that, let's actually, I guess, dive into how you would proceed. Let's see. Do I want to? Yeah, let me get rid of this now. Probably should have gotten rid of the arrays, but I'll show you roughly how to do the left first. So let's say that we are starting off with 0, 1, 1, 1, and 2. We have our start and end pointing to 0 and 2. And I'm going to, in blue, I'm going to define essentially what my range is currently, 0, 1, 2, 3, 4, with the range being the leftmost and the rightmost values. So mid after the first iteration is going to be obviously 0 plus 4 is 4 divided by 2 is 2. And let's say that target is equal to 1, right? So we see that target is 2. We say that mid is equal to 2. And at this point, we would rewrite end to equal to, we would rewrite mid to end to equal to mid. So all of a sudden, we are now just at this range. So end and start is now 0, end is now 2. Cool. Next iteration. What is our mid? Well, 0 plus 2 is 2, divided by 2 is 1. So that's our mid. Is this element in the range that we want to find? Yes, it is. So we would do 0, 1, 1, 1, 2. But now you're looking at 0, 1. Why? Because we rewrote end to equal mid. At this point, we are checking if what is the mid? The mid is 0 plus 1 divided by 2, which is 0. 0 plus 1 divided by 2, which is 0. What is this? 0 is less than the element that we want to find, so we say start is equal to mid. Sorry, no, start is equal to mid plus 1. And at this point, 0, 1, 1, 1, 2. At this point, you are left with just the 1. Both start and end are pointing to the same value, so we exit out of the loop. So let me now quickly show you how that code would look like. Start is equal to 0, end is equal to 0. Then we say while start is less than end. Again, this is the same code that the same pseudocode that I previously wrote. We do mid is equal to start plus end divided by 2. And then if target is, okay, and now let's remember what the logic was. If target is less than, sorry, if the target is greater than or equal to mid, nums mid, we're going to say, oh, sorry, no, we are looking for the leftmost. So, there we go. It's less than or equal to mid. We're going to say that end is equal to mid. What have we done here? We have now cut off this portion of the array. We're now looking at just 0, 1, 2 elements. But in this case right here, we're actually doing something else. We're cutting off the left. So what is this? Else. And then here is going to be start. equals mid plus 1. Well, perfect. There we go. So we have our code to find the leftmost element. Now, why is this? Why is this not enough? Well, because we need to find the rightmost element too. And what you're actually going to find is, let me rewrite this. And what you're actually going to find, and this is just a divide, is you can't really modify this code right here to suit our need of finding the rightmost value. Why? Because of a situation like this. Let's pretend that now you are, let's do this, I don't know, in red or in blue. Pretend that you are now trying to find the rightmost value, and you are left with a situation like this. 0, 1, that's the array, and you are trying to find this value, right? Target equals 1. Well, what you would do is you would still have the start is less than end, and so on. But the condition here would be something like this: if target is what? Let's say if the target is equal to or greater than, right? Equal to or greater than nums mid. What is the option that you have here? Mid is equal to 0, because 0 plus 1 divided by 2 is 0. If the target is smaller, I guess you could say if the target is greater than nums of mid, you would set it to start plus 1. You would set start is equal to mid plus 1. But see. I guess actually let's try doing that, because what I usually find is the situation where you have a 2-element array and you are trying to figure out which pointer to adjust, either the left or the right. You end up misaligning what you're actually trying to do. Misadjusting either the left or the right pointer. But that being said, let's actually try. Well, okay, I didn't finish. If target is greater than nums, then set start to mid plus 1, and then else, right? Else we would say end is equal to mid. That sounds about right. Let's actually do that. Sorry, I'm gonna send blue. I don't know why I had that. Anyway, yeah, and the mid would be found the same way. So I'm going to be referring to this code, but def find b binary find left, and I get the start and an array, and mid is equal to, as I said, start plus end divided by 2, while start is less than end. I'm going to say that if, and this is what is being highlighted in the green here, if target is less than, if target is less than or equal to nums mid, then all I want to do is say that end is equal to mid. Perfect. Else, start is equal to mid plus 1. And eventually return start. Okay, but here there is another situation. Let's say that start actually goes out of the scope of the array completely because it's not found. So what we actually need to do, or even better, on top of start going out of the scope of the array, let's say that it's this scenario, 6, and we do actually find where the place for the element would be, but there is no element. So we're going to say start if start is equal, if start is less than len nums, and start is equal, nums start is equal to target, else -1. Cool. This is to find the leftmost element. This is the pseudocode in green. Now let's do the same thing, but for the blue, for finding the rightmost. Def b find right. Start end r. Mid equals start plus end divided by 2. Same logic. While start is less than end, if start and here we not start. If target is greater than. So what we're trying to do here again is we're trying to eliminate the side of the array that we don't actually want to see. And in this case, if target is greater than the mid, I'm going to say that start is equal to mid plus 1. If target is greater than nums start, mid, then start is equal to mid plus 1, else end is equal to mid. Okay, so I'm relatively sure that there's going to be an issue here with basically an infinite loop, and let me quickly actually try to see when that would happen. Actually, let's just look at an example eventually. We're gonna run into that issue, and then return. We're gonna run into the issue if there is an issue. I would also say probably start, or would it be end this time? And if end is greater or equal to 0 and nums end is equal to target, else -1. And return b find left of 0, 0 len of nums -1 and nums, and the same thing here, but with find right. Let's run this. And I'm pretty sure we went into an infinite loop. And the infinite loop, I'm almost sure is here, because I'm pretty confident about this function here. Time limit exceeded. Let's see which cases are actually doing this. Let's use my example here. Target is equal to 1. And instead of finding this guy, let's just find, let's run through this logic on paper with this input. Cool. 0, 1. So I'm pretty sure that it's going to be pretty easy to find. Let's go. Target equals 1, and nums is 0, 1, 1, 1, 2. 0, 1, 1, 1, 2. Why does it not? Nums. There we go. At first iteration, we have these indices in our scope. Left is pointing, where start is pointing at 0, end is pointing at 4. we're saying that our target is 1. And by the way, we're doing this pseudocode right here, so I'll keep that in mind. Actually, let me just put this to the side. It's going to be easier to follow. And let me write here. End is equal to start. We also want mid. Mid is equal to start plus end divided by 2. Okay, so first iteration, we have all of these in scope. We find our mid, which is our 2, and all of a sudden, well, not all of a sudden, next iteration is going to be 0, 1, 1, 1, 2, but the numbers in scope are now just 2, 3, 4. 2, 3, 4, perfect. Next iteration, we find the middle. Middle is going to be 3. 3. 3 is, oh, okay. So, sorry, I haven't been following along to this here. What is the first iteration? If target is greater than or equals, if target is greater than nums, right? If target is greater than nums at mid, which it's not. Wait, I'm trying to find the rightmost. So if target is greater than mid, I would have to readjust start to, otherwise I would have to readjust end to mid. No, that doesn't work. Because in this case, target is equal to nums, and that just means that I have to readjust start to mid. So what am I doing here? Sorry, I completely messed up. What is the scenario here? If target is equal to, would it be just greater or equal to nums mid? Then I would say that start is equal to mid, right? Target is somewhere in the right portion of this array, so start is equal to mid. Else, if it's smaller then obviously I'm going to disregard this element entirely, and I'm going to go to the left. I'm going to say end is equal to mid minus 1. But isn't that identical to what I have here? If target is greater than, almost identical. Okay, so if target is greater than or equal to nums, then go to mid. To find the right, if target is greater than or equals to mid, then I'm going to say start is equal to mid, otherwise minus 1. Infinite loop again. So what is going on? It seems like I have this logic set up correctly, but let's see. If target is greater than or equals to num, then set start to mid. That's what I did here on this iteration here. Moving on to the next. 0, 1, 1, 1, 2. I'm in scope. I have now just these elements, or just these indices, 3 and 4. Okay, here we go. And here we hit the infinite loop. I have the, oops, it's not loading. I have the elements 3 and 4 in 2. actually it for some reason froze. Basically what I'm trying to say, and I can just show you this on the, yeah, there we go. If 3 and 4 are in the loop, I go into this infinite situation where 3 plus 4 is going to be 7. 7 divided by 2 is 3. So I again choose 3, and then I set start to mid over and over and over again. And basically what we end up doing is repeating this guy like endless amount of times, right? And that's not what we want. So I actually have a quick trick for it. I think we could theoretically just we could just check if we have hit the start minus start being less than end minus 1, which just means that we have 2 elements left in the array. And let's see. Start is equal to mid minus 1. I would need to do something like this. Once I find it, if end is smaller than 0, return -1. If nums mid end is equal to target, then we're returning end. If nums start, so basically what I want to do is I want to check both cases. I want to check that start is equal, if start is equal to end, and then if start is equal to target, and then if end is equal to target. Else return -1, and this could actually also be an elif. And this should work because we stopped iterating on the situation where we just have these two, 3 and 4, and since we know that we're never going to get down to a 3 because we're simply just reassigning mid to start over and over and over again. Did I do something wrong here? I didn't. Why did I count mid there? And since I am, oh wait, why did I didn't do this correctly over here. For some reason, yeah. Let's reset the test case. Yeah, to finding the right, it's always kind of confusing. I actually used to have issues with finding the left as well, until I realized that just having the end be inclusive and not exclusive just really does it for you. Finding the right, though, is more complicated because of the situation where you have the sum of start plus end equaling an odd number, like for example 7, and mid actually equaling start. Not well, actually, what you could do is you could take the ceiling of, actually wait, math ceiling of this, and then hold on. If I take the ceiling, then this should work. Start is equal to mid. I'm falling over to the right side. Oh, I didn't think about this earlier. Can I just do some symmetry here, essentially? Return end if end is greater or equal to 0 and nums end is equal to target, else -1. if target greater than, where am I going wrong here? It doesn't find the rightmost. Why doesn't it find the rightmost? If num's end is greater than target, should this just be start? No, this should be end. Wait, finding the right. Mid constantly gets reassigned to a smaller, end constantly gets reassigned to a smaller number. So I'm scared that at some point I'm going to assign end to negative number. So that's why I'm checking that end is greater than or equal to 0, and nums of end is equal to target, else -1. But then what am I doing wrong here? Mid is equal to math ceiling start plus end divided by 2. Okay, I'm very, that's why, because I'm now checking if it's, I forgot to get rid of that, but this should be symmetrical and this should actually work. Please work. No, time limit exceeded. Oh wait, I'm very desperate to get this to work. Start is equal to end, or start is smaller than end, and then math ceiling. So I'm constantly falling. Like for example, in this case where it's a 3 and a 4, I would default to a 4, and then in the case where target is less than, I would say that end is equal to mid -1. So end would be pointing to 1. Let me check this. Let me check my test case quickly, just so I'm not going crazy and that there's another scenario that I'm not taking into account. This should work. It does not. Where am I going wrong? In this scenario, 0 divided by 4 divided by 2 is 2, and target is equal to or greater than mid, so I set start to mid. Great, I'm pointing at 2 and 4. Next iteration. Next iteration, 2 plus 4 divided by 3. Divided by 2 is 3, and 3 is an even number, so I say 3 is start and 4 is end. 3 is start and 4 is end. Did I set this to a wrong number? No. 3 is start and 4 is end. And finally, what is 3 plus 4? 7. And there should be a 4 here. 7 divided by 2, but the ceiling of it is 4. So mid should be pointing at this number. I see that target is not greater than or equal to nums of mid. So I set my end to mid -1. And if end is greater than 0 and nums of, should I just say start? I mean, I'm essentially, oh my god, this is gonna drive me nuts. Yeah, I'm sorry, this video is, so I'll put a situation where I'll put a link to this solution once I get its start and print start end, I guess. and let me go back to what I wanted. And is greater than or equal to 0, and find right, find left. I'm doing everything correctly. Where am I messing up? I should just be seeing this almost one-to-one. Except I guess for the for this single scenario. And this 4 is actually going to be the mid. And this is running forever. And let's see. I'm looking at 3 and 4 over and over again. Yes, that's where I'm. But this should be mid. This should be a 4. And then target is not going to be. So end is just going to be equal to 3. So why is this going wrong? Am I using the incorrect? Let me look up math ceiling. I know what I'm doing. That's why. That's why. This is turning into an integer before math ceiling ever has the chance to put it up, to round it up. And that's why I'm getting I'm rounding down always. Okay, so this is gonna work. Perfect. Let's run this one more time. This is gonna be quick. Perfect. Cool. Reset test cases. Thank you for staying with me through this. Awesome. Okay, let's submit this. I guess you could also just have modified both of these arrays to, oh, look, I guess I've done this before, 2021. You could have modified the function a bit to not have to rewrite finding the left and finding the right, but this is, I think, totally acceptable. And yeah, I'm not gonna, and this is the same exact approach. Yeah, guys. So thank you for following through with this. This is the solution that I recommend, and please use it if you want. Hope that this is very intuitive, and kind of me struggling through this helped a bit. There's always issues that I have with with doing binary searches, specifically either the left or the right. But as long as you remember to treat the start and the end index as inclusive indices, and walk through a couple of scenarios. Like for example, I love to use 0, 1, 1, 1, and 2 because it very commonly catches pretty much all scenarios. If you walk through them, then this quick piece of code is usually enough. Okay, with that, thanks for watching. This is a bit long, but thanks for following through. See you later. Bye.